Hello, aspiring AI agent overlords, and welcome to our third class. We started our journey with little more than sophisticated chatbots. In our second session, we explored bots capable of some autonomous action, but we needed to hold their hand every step of the way. Today, we will work with agents which surf the web, click around, collect data, and make judgments on the fly with a scary level of independence.
I need your clothes, your boots, and your motorcycle.
To put it more broadly, these non-bodied folks we're going to meet make decisions. They are agents in the full sense of the word. We're going to talk about how these purely declarative agents work, dig into their minds, so to speak, and explore what pitfalls and unique affordances of this kind of self-determination and reasoning capacity imparts onto the software. To familiarize ourselves with these kinds of agents, we'll be using MultiOn, a leading product in this field. MultiOn is a natural language interface over your browser. It executes tasks that are way more abstract than what Zapier and other apps we considered in previous sessions could pull off. To put things simply, they can just click around on the screen, so anything you can imagine yourself doing in a browser, you can theoretically teach these agents to do it too. Let's drill down into what this difference between Zapier Central, which we delved into the last video, and MultiOn is exactly. Zapier Central performs concrete commands. With Zapier, you need to think through the logical process up front. It's not going to do it for you. And if you haven't instructed these elements explicitly, it will likely need the user's help. MultiOn, in most cases, will not turn to your help, unless it needs your password or something. It will error correct and tackle obstacles on the fly using its best judgment. Like MultiOn, Zapier Central does have a browser plugin which can process what is going on your screen, and it can do some pretty nifty things with that plugin. The limitation of Zapier, which MultiOn doesn't have, is that it can only process the written information currently on that page. It can't find its way between web pages to find the relevant content it needs. It only comprehends that page you visited. It can't manipulate the written information on the current page, but it can't deduce what action will follow from acting on the page itself. It can't just click on buttons and go from page to page and keep surfing the web the way you would until it finds what it's looking for. And this deduction element, that's the major leap. MultiOn is not just performing tasks, it is taking on some of the analytical load in attempting to achieve a distant end goal. For example, if I say go to my Gmail account and it arrives at a website and sees that it has a sign-in process, it will understand on its own that this is not my email server and it should not go on trying to graft an email on instead of my password.
Could you please verify if the password is correct or if there's any additional authentication step required?
So the whole credentialing process is different. I didn't do it beforehand, I do it on the go when the model realizes that that's a necessary step it needs to take. And this little concrete example reflects the general shift in my relationship with the agents when they become self-determining. We started our journey with the most imperative and deterministic agents. Today, on the other hand, I'm going to introduce you to the other far extreme of the declarative side. The agent is capable of attempting to execute tasks with more broad descriptions by taking on the unspoken elements and making decisions for itself. It is less human in the loop in its logic execution. Now, this doesn't mean that MultiOn is just completely uncontrollable like a teen that you've just sent off to college. It does have toggles just like Zapier does to offer guardrails and how it executes its commands. But these toggles operate in a completely different way. And today we'll get to understand how controlling these machines actually looks like. But before we get to see how exactly the rubber meets the road, let's talk about what is going on under the hood, or should I say, within the minds of these decision-making agents. It is easy to oversee the leap from Zapier Central to MultiOn because it is a leap we have made ourselves in a distant childhood. Because it feels so second nature to us as humans, the things that MultiOn does, we tend to undervalue the complexities involved in self-directed behavior. There are many elements to this leap which we tend to take for granted, but are actually enormous from a point of view of applied cognition. As someone with a master's degree in mental health and specializing in cognitive science specifically, I will do my very best to convey these subcomponents involved in agentic behavior while keeping things as much as I can practical and application oriented. As someone upstream who is trying to assess agents from a managerial and developer perspective, you need to become aware of the features MultiOn must possess in order to have a self-determining capacity. Drilling down into the conceptual layer will bring to light both their strengths and the biases which are unique to agents like these, and which did not characterize any of the software applications that we've explored so far. This in turn will help you identify the optimal and suboptimal use cases for agents like MultiOn. So, what are we talking about here exactly? The unique element of agents like MultiOn is what is called goal-oriented cognition. Let's break that term down. Goal-oriented, pursuing a specific end goal, and this goal could involve many substeps which are not self-evident or transparent. Cognition, a very broad term with many moving parts. But to put it broadly, cognition in this context is a set of information handling processes which allow us to interact with the world in a meaningful way. In other words, cognition is a way to manipulate information so it'll inform the means to an end. All large language models possess some degree of goal-oriented cognition. Otherwise, it wouldn't be able to understand your instructions and give you a sensible response. But non-agentic applications we are most familiar with are locked into a medium or a set of mediums, be that text or pictures or sounds. Agents, on the other hand, employ this capacity to achieve goals in the virtual space. They're not just handling text or pictures, they're using the text and pictures they see in order to achieve a specific end state in the internet. So let's crack open Pandora's box and dare ask ourselves, what does it take to cogitate or employ cognition? It is a field that'll take 6 years just to get a hang of, but we're going to ask ourselves, what are the elements of it that are specifically of importance to us? Some of these are already mastered by Zapier Central. MultiOn has to possess additional features on top of that to be able to freely browse and interact with the internet. What are these features? Well, here's 7 that I think are the most relevant. And the ones which we have seen with Zapier Central are pretty concrete and familiar to us. It's easy to say when a software is perceiving or remembering things and when it's not doing those things. But capacities possessed by MultiOn are more ambiguous and hard to put a finger on. When does it become obvious that a software is problem solving and not just executing pre-learned commands? So let's go through these one by one in a little more detail. In this Zapier plugin we just showed, we saw how action models are able to perceive the elements on the page and do something with information present. We saw how models are able to filter through this information in order to pull out the relevant content, and that's an element of attention. They direct their attention to the elements that are of actual importance. We have seen how Zapier can store the content to later upload it into Notion or LinkedIn or what have you. And of course, we saw how the model is able to interpret instructions in natural language from the user, make sense of it, and give back a response that is likewise in natural, free-form English. Now let's break down these more ambiguous elements. We've seen some form of problem solving in Zapier when we would ask it to troubleshoot an issue or break down a task into logical steps required to achieve them. And we've seen that the models are quite competent in this task decomposition capacity. But we all well know the chasm between planning on how we're going to do something in theory and trying to actually pull it off in practice. As a well-known saying goes, no plan survives first contact with implementation. In the real world, things are just much more messy than our plans. Additional impediments and nuances inevitably arise. So a self-determining agent will need to know how to modify its plan and make unexpected decisions on the fly. The agent needs to see what's going on, comprehend when the situation is not what it expected, and make decisions on the go as to what to do with the arising impediments. Which brings us to our second component of cognition. Decision-making in this context is about being presented with multiple options and committing to one of them without always having complete information on the outcome of that choice when making it. This is something Zapier Central was lacking in. If it was missing some information about how to handle an API call, it will do its best to remedy it, but then just throw up an error. It'll just have no idea how to move forward. What it wouldn't do is go to the actual website and try to make sense of a situation based on what it sees. Now this impediment is true only as of July of 2024. It could very well be that Zapier will upgrade to something more interactive in the near future. So how does decision making work? Well, making decisions in the real world requires what is called heuristics, or rules of thumb on how to act in ambiguous situations. Heuristics are used to prune decision-making trees, allowing the agent to navigate complex situation spaces more efficiently, even ones it has never seen before. For example, MultiOn can be presented with a website it never visited before, and for which the developers never programmed an API call, and for which it was never meant to be prepared for out of the box. And yet, it could still navigate it and extract useful information out of it. MultiOn possesses a schema, or a general understanding of how websites generally work and the functionalities that the buttons in particular locations usually carry. It's overarching takeaways about the internet and how it works, which are then applied to specific websites. Schemas are categories or templates that we use to classify and understand the world around us. In just the same way, the agent uses schemas about the internet and websites in order to navigate them and extract insights as to what the buttons do. Using these schemas, MultiOn can apply general rules of thumb or heuristics that are most relevant to that context. Like, for example, that a word and a blue circle around it is a button, and the word inside that blue button describes the functionality of that button. These are the kind of things that are painfully obvious to us, specifically because we're so accustomed to using schemas and heuristics to navigate our behavior. So when considering agents like MultiOn, think of what tasks that you perform repeatedly require you to come in contact with new circumstances, novel websites, and interfaces. When do you interact with software that don't have an API at all, and so cannot be inherently plugged into something like Zapier Central? Or when do you lack specific instructionals that you could convey to a model in order to instruct it to navigate them? These are the types of situations in which we as humans rely on schemas and heuristics in order to navigate through the impediments, and for which agents like MultiOn are best fit for. However, heuristics are not one size fits all. Because we're relying on general rules, inevitably they will run into problems when applied to edge use cases. Heuristics might be a poor guide in unexpected situations which are completely do not fit with the expectations. Generalizations are just that, generalizations. They gloss over exceptions in return for efficiency and universality. So there are situations where Zapier Central might actually outperform MultiOn because it operates on pre-programmed API. It knows the specific language that a particular app prefers and the different options it possesses. It doesn't lean on rules of thumb on how the websites in general work. It acts on specific instructions. MultiOn does not have that knowledge base. It operates on heuristics and inferences alone. Reasoning through heuristics predisposes a model to the biases we ourselves are all too familiar with as humans. Some of these may include hasty generalizations, or drawing conclusions based on a small or unrepresentative data. And you'll actually get to see this when I ask MultiOn to pull some information from the internet. What it will likely do is scroll through the first 3 websites when scouring the internet for information and start generating content satisfied with that first insight. Sometimes that first insight is on point, and sometimes it's misrepresentative. Another bias it might fall victim to is called false cause, or misascribing causality when actually there is none. It will see that something happened after it did something to another part of a website, and assume that that result was a result of the way it engaged it. A third bias, and probably the most common one, is what's called biased assimilation, or interpreting ambiguous information in a way that supports its generalizations. So it might expect that clicking on a title under a video will take it to a transcript or additional options, when in fact with interfaces like Fathom, you have to click on the video itself in order to reach the additional information. A fourth type of bias that is common is what is called circular reasoning, which gets the MultiOn into these hilarious situations.
I am clearing the previous text and pasting the copied transcript into the email body again. I'm clearing the previous text in the email body and pasting the copied transcript again. I am clearing the previous text in the email body and paste.
And this is something that actually happened to my colleague Jeremy, who asked him to post something on LinkedIn, and for some reason didn't get the confirmation that the post was successfully made, and it started just redoing the post over and over again. And back then, MultiOn was much more experimental, and Jeremy didn't even find a way to stop it, except for by closing the browser altogether. Alright, so now that we are aware of these biases that we might fall victim to, how can we address these biases? Well, one is to check in periodically to make sure the agent's schema or conceptualizations of what's going on do not differ significantly from your own understandings, which is probably the more correct one. And we will show you how you can turn on an option for MultiOn in which the agent is going to check in with you periodically before endeavoring into the next large step of the process. There's still some demand for a human in the loop because if the agent's understanding of a website and its functionality is wrong, it will miss important information or overemphasize information that isn't relevant. In other words, its attention will be thwarted and augmented in a wrong way. So here, a great method is to provide the model with what is called a show and tell. This is a brand new functionality MultiOn just implemented. I believe it'll be much more widespread when these agents will become common sense. But we can at least show you in theory how that show and tell would look like. So that's a little sneak preview of psychology and of a conceptual basis for the class. Now let me show you how these agents will execute on a row of tasks that I've prepared. There isn't going to be much of a lot of specific instructionals on like buttons and prompts because, well, the whole point of these agents is to relieve you of that necessity. Instead, I will show you a diverse set of tasks that this agent is going to execute, some snags that it might run into on the way, and help you brainstorm how you can play with toggles in the input prompt in order to maximize the agent's success. So first let me walk you through Zapier Desktop because it'll show you the leap in concept from a purely language processing agent to one that is actually maneuvering through your desktop. So you'd install Zapier Desktop the way you would any plugin. You just go to extensions and select Chrome Web Store and then search for Zapier Central in the extension store. And you add it to Chrome as an extension, add extension. Alright, so the app has been added. And now check this out. So I'm going to go to my LinkedIn and pin the Zapier Central extension to my taskbar. I'm going to click on it and it'll open the side view through which I can employ assistants onto my screen just like I would with MultiOn. So as you can see, this is a leap from the Zapier Central we've been exploring before because that one reaches out to outside apps without actually taking over your browser. So here I'm going to ask it to summarize the content on my LinkedIn page and give me back summaries of every single post that was made on there. And so here it is. So here it is processing the language that is on my screen. It is not clicking on any buttons, not trying to interpret their functionality. It's just scanning the words that are on my screen, ripping them off, and passing them through a large language model. And I'm going to give this tool a name, and then I can refer back to it whenever I want to summarize link pages again. I could just always click back on that specific bot and install that as the behavior, or since I'm just cutting corners here, just posting the same prompt again. And voila, there's another summary of an updated LinkedIn page. And by clicking these triple buttons in the corner, you can select Add Assistant settings and actually access all of those previous bot functionalities you've created through your Zapier desktop without the plugin. So as you can see, it still has my same post. I can still add actions to it, like post this stuff to Notion. So this should look familiar to you. I'm going to select Create Page. Now that action is built into my Notion. And I can likewise select data sources and add past data, so whatever is generated off that page can be informed by some previous data point that I've inserted earlier on. So as you can see, now the create page option is on my Zapier desktop, and I can add additional instructions to it, like add these summaries with which specific page to post it on, and I can do that in natural language and execute as requested. And as you can see, I can even select my personal AI assistant, which we created in video 2, to help me out with my current browser actions. So for example, I want to summarize an article by Jeremy Kirschbaum and add it as a task to proofread it and send it back. As long as I physically go to Jeremy's page and actually click through the buttons, this agent is capable of doing all the things we've seen in video 2. It can add a task card, estimate the duration for how long that task is going to take, and post all of that on Notion just because I've shown it how to do all that previously. So as you can see, it's pretty good at making long-winded summaries and processing large bodies of information in an effective way. It did a great job reaching into my Excel sheet and pulling out the relevant information to estimate that proofreading this document is probably going to take around 4.5 hours, which is pretty reasonable, and it successfully created the task card. But Zapier was having a bad day that day, so no matter how much I prompted it to actually post that art summary into my Notion card, it just wouldn't do it for some reason. I tried giving way more specific instructions. I've tried copying and pasting the summary physically into the prompt and asking it to just post whatever it's seeing on the page, and none of that worked. Again, this is only true as of April of 2024, so very likely that Zapier is going to tackle all these issues moving forward. And now that you've seen the general workings of Zapier Central, let me show you how MultiOn works and bring your attention not just to functionally, but also the conceptually that MultiOn takes on in order to achieve a much wider breadth of tasks. If you followed the instructions attached to the videos, you should have received an email with an option to download the browser extension. So if you click on that, it'll take you again to the Chrome extension store, and you'll click to add that MultiOn extension to Chrome. And just like that, you get MultiOn. If you didn't go through the process, you can just sign up for a playground. It's basically the same thing, just a different interface, and I'll be showing both of you today. So when you log in, it wants you to introduce yourself, ask all these additional questions, and It has a traditional profile page. And below it has some options, such as like, you want to hear the voice of the agent as it's going through the steps. And I've showed it to you previously. I'm going to turn it off now so I can show you what's going on. And then there's this notes section, which works in a pretty interesting way. This is basically like the system prompt that we explored in video 1, which just gets attached to every single command that you put in. And I should have mentioned this previously, but this is actually one of the methods of which you can control the bot and buffer it against those more subjective mistakes which are specific to your use case and your preferences. So here, as you can see, as an example, they tell you that you can state that you always prefer window seats when booking an airplane flight, because one of MultiOn's showcases shows you how you can actually book a flight by just using MultiOn commands. Here you can add all kinds of specifiers, like that you always want to log into a specific Gmail account, or that you want your Uber ride to be a specific way, and the prompt will be applied only in contexts which are relevant to it. There's different kinds of AI modes. Some are fast, and I'm not sure what ludicrous is. There's trigger mode, which is, do you want it to just run through the steps without checking back in with you until it runs into an issue? Or do you want it to check in with you at every step before it performs any subsequent major operation? So this is what the playground looks like. This is not the plugin. This is just going through your browser, and as you can see, it has a mini browser inside of it, which is basically the same thing as what the extension does. And I can ask it questions like, what's the NVIDIA stock today? And it will roam the internet and pull up the stock as I request it. Not very impressive, but trust me, it's going to get crazier from here. And as I said, I think you can access the playground by just clicking the link. You don't need to go through the Discord sign-up process that you would need for the extension. But if you did get the extension, it should pop up in your extension list. And again, I would suggest pin it to the taskbar. And then you should see this little window which has API call and show assistance. You want to make sure that show assistance tab is turned on. So then you should arrive at a page like this. And if it does not pop up immediately, try closing the Chrome tab and opening a new one, and it should load up onto the MultiOn page automatically. So as our first test for MultiOn, let's try to replicate the process we tried to do with Zapier Central. So what the agent's going to do is it's going to locate a specific article on LinkedIn from a specific person, summarize that article using a large language model, and then post that summary onto my own LinkedIn page. So quite a few pages to navigate through here, with a data manipulation step in the middle to employ that LLM reasoning ability into our process. And so to execute that, I'm going to put in the prompt that says, go to LinkedIn, search for the account Jeremy Kirschbaum, which, by the way, as you can see, there's a typo here, and let's see how the model processes that typo. And moving forward, among my contacts, go to the section of LinkedIn which is his articles, open his latest article, make a one-paragraph summary of the article, and post it on my LinkedIn feed. And here's me firing off that prompt, so I just put it in the text box, and now I'm going to click do it. And I'm actually going to turn on the step mode right away, because it seems like a quite complex process, and I'm interested to see when it's going to check in with me on whether the process is correct. So I'm going to go up here where it says auto and step under the MultiOn heading and click on step. And as you can see, right away it goes to my LinkedIn page. And it navigates to Jeremy Kirschbaum's correct page, even though it's misspelled, so there's some heuristics going on here where it kind of understands that I'll probably be looking on LinkedIn for people that I know, and instead of returning an error message, it saw an option that Jeremy Kirschbaum is in the search and guessed that that's probably what I'm looking for. And then as you can see, it's correctly navigating to his article. And now it's scrolling down through his article in order to actually see it on my browser in order to memorize it for the summary. So as you can see, it's not going into the HTML file and on the front end code and pulling it from there the way a search scraper would do it, or likely something like what Zapier would do. Instead, it's actually observing what I'm observing and reading what I'm reading in order to make the summary. So it has to take over my browser and simulate a human experience, unlike all our previous agents, in order to comprehend the information. And here it's posting the summary of the article into the chat box and asking me to verify whether that summary is good enough. So I was doing this specifically because I turned to step mode. If I turned auto, it would just assume that the summary is good enough and go ahead and proceed with instructions. So then it goes into my LinkedIn post and it goes ahead and posts that summary. As you can see, it's correctly finding the buttons on which mean to make a new post and opening the appropriate windows. None of this was pre-programmed. This is just it reasoning through the page, and voila, it made the post. So as you can see, it created the post, a little window popped up in the bottom left corner, which was saying like, oh, the post was successful, you did a good job. But it didn't realize that message was in relation to its current actions. So it misattributed that message as being irrelevant, and as a result got stuck in a loop, recreating that same post, which is something similar to what Jeremy was going through. It reposts a new summary. This one is actually longer and bigger, and it's going to try to spam this poor group that I happened to sign up for with just another post. Thankfully, this time I made a mistake. The post is too long, so for some reason the recreated summary was longer, forgot my one paragraph instructions at this point. I try to tell it like, hey look, this summary is now longer and too long. Try to do it the same way but shorter and just repost it again. But thankfully for the group I was spamming, that's at the point at which the MultiOn app crashed entirely. So from a purely objective point of view, this task was failed by MultiOn, but I'm not even here trying to like judge it as failure or pass, because that's going to change by tomorrow. What I'd rather look at is what kind of biases and control systems we employed in order to try to execute on this app. Can't say I saw the agent fall victim to hasty generalizations. It read through the entire article and made a comprehensive summary, which was a pretty good reflection of the article. It did, however, misascribe causality and did not correctly ascribe the message saying that the post was successful as confirmation that it has completed the task it was asked to do, which led to the bias of circular reasoning. As we have seen, it retried to post the article, it even went to LinkedIn's support page to look for solutions, and ended up in a loop which would have posted LinkedIn articles indefinitely had it not crashed. And with that, let's move on to test 2, which in my opinion get increasingly more difficult, because now we're not telling it to look for in a specific location for information, we're telling it to search the general internet for information that best fits with our interests. So what it's going to do is it's going to search the web for articles on the intersection of virology and generative AI. I've intentionally left that description ambiguous to see how it'll handle that ambiguity. It's going to generate a summary of the interesting facts that it found in those articles and then post those into my email and send that out to myself in this case, but it could have been somebody else just as well. So my prompt goes, find an article about the intersection of virology and generative AI, summarize the article, email this summary to lev@handshake.fyi. I'm ready to send in, send without asking me for confirmation. And I'll show you the difficulties and problem solving capacities of agents when trying to log into an account in a separate video. So like before, I'm going to go to MultiOn. Again, just open a new tab in order to pull up this window, slap in the prompt, click do it. And it's going to do some planning. It's going to right away realize that it needs to search for some new information. So it's going to go to Google. It's going to ignore the first articles. I'm guessing it because it realizes that goes to Google Scholarly. Now there's not something it wants to mess with right now. Instead, it's going to go to the article that is the first actual link to a real page. Now, it didn't go into much detail considering what angle it wants to take in exploring the subjects. It just literally typed in verbatim virology and generative AI into the Google search and pulled up the most recent article. So definitely not how a human would approach this problem. They would at least identify the ambiguity of a subject matter and maybe check in with me as to a more specific subject line. But to the model, search terms are search terms, so it's just doing it the way it sees fit. So now you can see it's actively scrolling through a web page to look through the top information and memorize it and paste a summary of it into the chat box. So again, a comically small subset of data that is considered before going and proceeding with the next steps. And it's saying I'm navigating to Gmail, and since I'm already logged in, it's not hitting any login barriers. It right away clicks on create a new email, copies the summary into the body, and sends it off to me. And this is the email I got as a recipient. And as you can see, it has a quite sensible introduction and a description of how generative AI is going to make an impact on public health. It didn't once mention virology as a field. It just said infectious diseases and healthcare disparities, which is a pretty broad interpretation of my instructions. Oh, and I see at the bottom it does say it can significantly aid in detection and management of viral outbreaks. Alright, so it did deliver, but the size of the dataset I was working with was absolutely not reliable, and so not representative that I would actually consider the searching capacity to be a failure at this point. As before, let's check our biases. I think this was a quintessential example of hasty generalizations. And to remind you, the reason why we're focusing on general biases and cognitive error rather than specific bugs is because the bugs are going to go away, but these biases, which are inherent to any communication relationships between two reasoning beings, are going to stay. They might be mediated a little bit by the developers of the agent, but the general issue of ambiguous instructions and how much depth and research is required for a task is going to remain an open question. There's no one right answer as to how many links you should pull before you are satisfied and begin to write the piece. So how could we have buffered for this issue? Well, definitely not show and tell, because that's not the type of skill set that you convey by showing an exemplar process. I think checking every step of a way would be the best approach. It's kind of hard of MultiOn to have it stop at a specific step and not go anywhere. It kind of checks in with you where it sees fit. So what you would do here is actually in your prompt be like, research your first article and then stop and check in with me, and then you would run that command multiple times before letting it proceed to the rest of the instructions. As our next test, let's ask the model to find specific information, not just general search, like, oh, just find something interesting on the subject matter, but a specific formula for a specific application. In this case, the most typical physics problem in the world, how to calculate the distance that a cannonball will fly once it's shot out of a cannon at a particular angle. Let's see if MultiOn is able to look up online the proper formula to solve this question, apply the calculation, and give me back a correct result. Alright, so here we go, MultiOn, we're rooting for you. Let's see if you can find that formula, which I don't even know what it looks like. Much to the embarrassment of my physicist parents. So we see it's going on Google. I think it's going to use the AI overview, funnily enough, that is at the top of a page to find the formula, because it does actually paste it in there. Oh, no, it decided to go on a separate page, some study smarter, which is hopefully a reliable source of information. So now it's getting spammed by pop-ups, but it seemed unfazed. It seems like it has some superpower in being able to see what's behind all those pop-ups and scan the information anyways, which is something I wish I could do. So it's scrolling through a page that seems to have relevant information. It's clicking on links that seem most relevant to my question. So it's clicking on a page, the trajectory of projectiles. It's memorizing a formula that it found on there, but it's not satisfied. Actually, it keeps looking, which is interesting. I wonder why when asking about virology, it was satisfied with the first 3 sentences and found when it comes to looking for formulas, it is much more thorough. I suspect that the agent understands this. This is a much less error-prone question than just a general question on subject matter, and so is double-checking itself, but I'm not sure. And it found an equation. It's doing a bunch of calculations. There's some sine-cosine operations. There seems to be some complex math involved, and it's giving me an answer of 172 meters distance. Now, I can't remember formulas from high school to save my life, so I'm just going to turn to Claude, another large language model, to make the calculation for me and double-check the results. And when I plug in my question, it's saying that 100 miles per hour is an incredibly slow velocity for a cannonball, so it wouldn't be expected to fly even a couple meters away from a cannon. Which I meant miles per hour, but now I'm realizing it's very ambiguous, and assuming that the agent thinks in imperial units, which of course it should, because those are the only true units in the world. So I kind of threw it a curveball and gave it this very unrealistic number to work with. Nonetheless, the answer is wrong, and I think a major part of this is because I gave it a very non-typical parameter. So I'm actually going to go back and try again with a more standard parameter for the exit velocity of a cannonball and see if it calculates the equation again. So again, it's putting it in search. It is not relying on the AI search. It's actually relying on the traditional Google suggestions, which pulled out a different formula, which this time seems to be correct from what I recall from high school. And it gave me a new answer. It gave me now 9.1 kilometers. And now let's see if that actually is correct. And it actually seems like it got the operation right this time. So here I must give to MultiOn that it did successfully execute on this quite complicated command, which even I, independently as a human, might have not actually been able to do. Now, what did we learn here? So we've seen how the agent's response is only as good as his Google search, and Google search can be all over the place. We've seen the inherent unpredictability of agents and how even posing the same question by just changing the parameters a little bit could very well send it on a very different decision-making track and have it arrive at a very different result. And we've learned that models, and by extension agents, are actually quite good at making numerical calculations and applying them to formulas with unknown variables. Test number 4. So here, instead of taking it to an intuitive website like LinkedIn, in which all the buttons are signed with words, and the general schema we would apply to websites would be a good guide in navigating LinkedIn, we're going to go to an AI note-taker website, which has videos uploaded from my past meetings, and there the navigation is not so intuitive. It's a pretty original application, and it has a pretty original UI. So the procedure that the agent's going to take is they're going to go to the Fathom Note Taker website, log into my account, click on the first video that has been last uploaded to that account. On the page dedicated to that video is going to look for a button that allows it to copy the transcript, copy it into my clipboard, and then navigate the Gmail and then paste it into the body of the email. Alright, and here we go. So as you can see, I'm not using the extension anymore. I'm using the MultiOn website, which you should have access to without going through any Discord login. I'm sending the prompt to go to Fathom Video. It goes to that website right away, which actually .video is not transparently a website, so pretty good intuition there. It's trying to sign in. It's seeing that I'm logged out. This is intentionally why I used the website version and not the plugin, because that way I'm automatically logged out of all my accounts, simply because I'm using a browser within the browser. It's seeing a couple of options, it's realizing it doesn't know which one's the best, and it's actually checking in with me, even though I didn't click step, it's checking in with me like, hey, which of these do you want to sign in? Which, even though it's in auto mode, it intuitively knows that it can't know the right answer there. All 3 options are equally valid. And I tell it, well, click on the Google one and log in with the lev@handshake.foi email, which it proceeds with both of those steps. That's for my password, and I just the same way, I type it into the chat and tell it what the password is. Now here's where it gets thrown off. So there's a two-step verification. I need to confirm this number on my phone, but the model doesn't know that. It doesn't know that I need a second to go to my phone and confirm that number. So it goes straight up to clicking further buttons. It interpreted this barrier as a message that this method of logging in is not going to work. And so right away, it just, without waiting or confirming, it moved on to alternative ways to sign in. And it ran into all of these options. And then it was kind of stuck. It was like, I don't know which one of these to use. And so only then did it started checking back in with me, which was a little too late. So I started the process all over again, yet again. I told it all the login information, and then I was sitting on my phone, and upon clicking try another time, I clicked on the number as soon as it popped up before the agent could proceed and start derailing the process. So some very important cognitive methodologies employed here. First of all, knowing when a choice is ambiguous and not like there's one good choice to be selected from. Second is misinterpreting the instructions on the screen as something that the user is prompted to do, but is misdescribing it as an impassable obstacle and right away proceeding with alternative strategies. So we've seen outcomes of both good and bad heuristics here. I'm sure as we move forward with agents, the schema is going to be modified so it'll understand when it sees a cell phone confirmation page and just check in with the user as needed. Now that the login nightmare is behind us, I told it to just proceed with the instructions that I provided earlier, which to remind you again to navigate to the first video and copy the transcript from there. So this time around it actually did click on the video image itself and not on the title under it, which is a UI specific to Fathom, and somehow it figured it out that this time around that's the proper course of action. Last time it would click on the title, which would offer to change the name of the video, which would make it totally confused and not know how to proceed. Here, it seemed to outsmart Fathom and take the right course of action. Once on the actual page, which you can see is not a traditional looking web page, doesn't look like YouTube or any other website that at least I've seen before, yet the agent understood correctly that there's 3 tabs at the bottom, which is Summary, Transcript, and Ask Fathom, and it realized correctly that those are buttons and I need to click on Transcript. And then it didn't actually start scrolling through a transcript and copying it over, even though it would have been really easy to assume that's what I want from the instructions. Instead, it saw the button copy transcript on the screen and realized that it can take that shortcut and go that route, which again is a portrayal of reasoning and autonomously choosing the best course of action. Another moment of correctly ascribing causality here is when you click copy transcript, this done notification pops up in the top right corner, which to us intuitively of course means that we're done copying the transcript, but to the model, this is actually a causational relationship that is far from obvious. There's nothing about the notification that describes what it's in relation to. Yet MultiOn correctly identified that this done button is in relation to what action that it just took. Then it proceeds to my Gmail. All of this should look familiar now. opens Gmail and tries to paste it, but I don't think it has a Control-C, Control-V power functionality in it. I think it would need access not just to my browser, but my entire computer in order to copy and paste content. I don't think it has access to my keyboard to like click paste or right click and click paste. It pasted just a space bar and then misattributed that as to job well done. And I kept prompting it. I even copied and pasted verbatim the words it's supposed to put into the email from what it said earlier. And funnily enough, it was like, I don't understand what these words are. What are you talking about? I'm like, no, you don't understand. This is what I want you to put in the email. Just put that in. And it's like, sure thing, I'll do that. And then proceeded to not do that. So for all practical purposes, I know you're going to assume that MultiOn deserves a failure on this task, but I actually don't think that's fair because its application of schema and its ability to navigate novel websites, it was so impressive that I think this deserves a stamp of success. Now, hear me out, because as I said, we are prone to ascribing something that's very simple just because we can do it. But take a look at what the model was able to pull off, because this is going to inform your decision making on when to turn to these purely self-determining types of agents. The model successfully applied schema when going into Fablin.video and realizing that my personal recordings are probably not going to just be hanging out on the front page. A mistake it actually did end up making in another run-through. But this time it realized on its own it needs to sign in order to access my videos. Once clicking the sign in page, it realized that it did not reach the page with videos, but actually some kind of login process, just by appreciating what it's looking at. Continuing to apply its Sherlock Holmes skills, it clicked on the image with the video, as opposed to clicking on the title. From there, it was able to correctly locate the button that would take it to the transcript. And once it arrived at the transcript, it realized that there's a special button which, if it clicked it, it would get a copy of the transcript in the clipboard. And it correctly applied causational deduction in order to understand when the transcript was successfully copied over. And I'm going to do one more test to really bring home this strength that these self-determining agents have in applying schema and heuristics to navigate through forks in the decision-making tree, find ways out of ambiguous situations, and generally make sense of websites which are not transparent or traditional in how they function. So here's a website that I loved for searching for music. It's called Every Noise at Once. It was created by an ex-employee of Spotify, and as you can see, it follows a very non-traditional layout. It's literally just an assortment of bands and genres all piled together on a timeline from the oldest to the most recent ones. So what we're going to ask MultiOn to do is go to this website, find a specific genre, go to that genre's page, and then play the most popular band from the genre, which is decided by how large the font is of the band name. So the more popular the band, the larger its font is on the main page. So here I go firing off that prompt, saying I'm going to go to navigate to Every Noise at Once, which is amazing because I didn't say everynoise.com. I said Every Noise at Once website, and somehow it understood that this is exactly the website I'm talking about, even though it's by far not a very popular site. It correctly clicks on the genre it asked for, which is tech house, and it starts playing that music.
I'm clicking on the genre tech house to reveal the tiny double arrow that will navigate to the page dedicated to that genre.
Now here's the trick, is in order to navigate to the page that is listing the band names specific to that genre, it needs to click on the tiny little arrows that appear right next to the genre name, which appear only after it already clicked on the genre titles. But I specifically specified in the prompt that that was going to happen and that it needs to click on the genre name to get the arrows and to click on those arrows, and it precisely understood my instructions. From there, it correctly deduced that the band that is the most popular is the one with the highest font, and correctly selected the band that is the most popular in that genre. I'm also getting this feeling that this test was a major success. It navigated this very unintuitive website, which I think even I was at a loss for when I first visited it, and delivered on my end goal without any additional prompts. Now you might be saying, well, that was kind of cheating because your prompt gave very clear instructions on where to look for that arrow and what to click. And yes, that tiny part was explicitly described, but all the other elements, like that those band genre names were clickable buttons, and then selecting the most popular band, all those things, it required a lot of intuition and applied heuristics, which allowed the model to navigate to the end goal very much successfully. But wouldn't it have been nice if we didn't have to write out this very long prompt and think ahead of time on where to bring the agent's attention to make sure it doesn't slip up? Well, yes, it would be nice. And so this is a great opportunity for me to finally show you what Show and Tell is all about. The official name for MultiOn is called Lessons, and it's the only agent that I've seen of such capacity, but I think it would be a widespread practice by the time agents roll out into the larger market. And let me quickly show you how lessons work, or at least how they're supposed to work. So what I would do is click on the MultiOn little icon on the very right hand corner, and you'll get the options Profile, Lessons, or Chat. And you want to click on Lessons, and you'll get this little window at the bottom that says Recording Lesson, and then it says Start. And so you want to click Start, and it'll start recording whatever's going on your screen. It's just a standard video at this point, the way you do Zoom screenshots. And then you would go through a process of what you want to do. So I'm just going to repeat the process from test 5. So I've shown it how to do that process. Click Stop. And now it's going to ask me for a title and notes to the agent as to what is going on here. So if I specify in these notes, click on the double arrows next to the title like it did in the prompt, it will get integrated into the lesson. I actually tested it and it works. But I want to see if it'll catch on to this thing automatically without me prompting it, so I'm just going to give it a very generic description that this is something that I use to pull out my favorite song out of a specific genre, and I'm making this lesson so it can repeat that process. So now it's going to load up the lesson for a second, and voila, it created the lesson with a proper title that I gave it. And there's a prompt down here, which if you click run, you'll actually see the entire prompt. And as you can see, it's using its own syntax to organize the prompt. It's not using Markdown, it's using these star formations. And then it's just giving a description of what was going on the screen. And there's really nothing else to lessons. Like when I first saw it, I thought they were going to feed the video into the agent somehow and make it repeat exactly what I did, but with slightly different parameters. No, it's literally just taking what was going on a screen and transforming that into a written prompt, just like describing for itself what was done so it can feed back that instruction to itself and recreate the experience. And how good is it at recreating the experience from its own prompt? Well, not so good. It just it started playing Tech House, but then it started looking for other genres. Somehow it wasn't satisfied. Or maybe it was looking for double arrows way in the nethers of a website. I'm not sure. Either way, I think models still have some way to go in order to make very algorithmic descriptions which can be followed without fail. Just as I expect agents to take a while to follow explicit instructions without a single flaw in order to achieve some very complex tasks. But we're not looking out into today, we're looking into tomorrow, and tomorrow it could very well be that these agents can generate prompts from themselves by just watching what you're doing on your screen, and something like that might be actually built into your operating system to automatically automate the repetitive activities that you perform on your computer. But I want to bring your attention to the fact that this merging of schemas and building mutual understanding, that obstacle is never going to fully go away because it's inherent in the way humans communicate. And so it's imperative to be aware of these schemas and the heuristics that the model operates on and what types of heuristics there are. So either through prompting or lessons, which we've seen is just another way of prompting, or monitoring the agent's behavior step by step, you can be sure to bridge those two schemas and make sure that there aren't any costly mistakes made on the way. So now that this 3-session course introduced you to a variety of agent types, let's think about what's going to happen in the future. What are agents going to be like and what impact are we going to have? Well, in the near term, agents relying on specific tips and tricks to navigate software will likely outperform the ones that are more freeform. Software like Zapier will outperform MultiOn when handling specific apps which it was predisposed to and for which it knows specific toggles for handling that app. This is because self-determining agents haven't matured yet. We have seen how they often run into issues in performing basic tasks. But as this technology matures, self-determining agents will become more preferred to agents which require preliminary instructions. There's less preparation work involved. And the application, in the end, is more universal than an agent that you've specifically prepared to perform a specific task. And this brings us to many pressing questions. What will the online world look like when there are more agents roaming it than humans? How will they interact with each other? And how will the nature of the internet change as it conforms not to just us, but also to these agents? These are the questions I'll be leaving you with as we close out our course on AI agents. Please comment on a video with your thoughts, reach out to us, and be sure to explore our resource hub for additional insights on the world of AI. Thank you for joining us on our journey, and best of luck in realizing your ambitions in this brave new world.